Hello. Uh, Today we're going to be talking about function rules and basically just talking about functions in general. Okay, so let me just get right to it. Basically, a function is basically um, you can look at it like a machine. You have something, and then once you put a machine that does a specific task, and that specific task is by the equation that you have. It's the function itself. You put something into that machine and then you get something out. In this case, uh, you can look at it uh, like a car. In order to get it moving, you have to put gas, and then but it depends or let's say you go for your car uh, is efficient, and but no matter how efficient you go, it only goes a certain amount of distance. The amount of gas that you put into it is considered your input, and then your output is your how far can you go with that amount of gas, or in this case, that amount of input. So basically, it's like a machine. You put something into it, you get something out of it. Input and then an output after it goes through the machine. Now, let's see what we have here. In this case, usually we put y for the output, or like in um, an equation of a line, we usually a linear function. We usually write y as the output and then x as the input. It's usually the customary thing to do. As you could tell, it's a machine, or you can look at it like a machine. You put a -10 into this equation, and then after you do your math, you get -16 out. So let's just do that. Let's see. Or what, we got a -10 here. We got to put -10 in here. So we got 2 times -10 plus 4. Well, negative or 2 times -10 is -20, and then -20 plus 4 is 16. -16 though, because we gotta remember that negative. So -20 plus 4 is -16, which is exactly that. And then over here, we put -5 inside, or replace x with a -5. So we got 2 times -5, which is -10. -10 plus 4 is -6. So we're just we're putting an input into it. And then after we do our math, we get an output. Our y is the output. So we got y is equal to uh, this number whenever we put x is equal to whatever the number that we put. So that's why it's like directly across. So we put this number in, we get this number out. We put this number in, we get this number out. That's why it's like in a straight line. Now, that's pretty much it. Yeah, or here's like what I was saying, the -10. Yeah, we replace the x with a -10. I always like doing the parentheses, like how it shows here. And we got -20 plus 4 is -16, which is the output. So the input is actually this. Whoops. This is not pointing to the right thing. Let me just draw the line. It's that -10 right there. That's the input. And then the x, or whenever they said find y when x is 0, it's basically telling you what do you get? What is your output when you put x as equal to 0, or when you put 0 as for your input. That's basically what it is. They're telling you right now, but they're just saying it in a different way. So whenever they say find y uh, when x is equal to something, they're basically saying like, okay, well, what is your output when you put this number as your input? So let's see. We have this equation. Okay, we got 3. Let me just write over here. They're telling you this is your function. This is your machine. This part is your machine, basically. You're putting in well, the whole thing is your machine, but like the thing that you're doing work is on this area right here. And it's asking you when x is 0. So they broke it down as y, or well, they didn't put the y, but it's equal to, yeah, y it's always equal to. But now it is 3. Oops. They say when x is 0, so you just replace x with a 0. We got plus 1. So we got 3 times 0, which is 0, plus 1, which is just 1. So your output is 1 when your input is 0. So this will be your output. This is for number 1, or actually it says number 4, but I'm just going to write down 1. And then I'm just going to do it this way. It says what is y when x is equal to 1? That's what it's saying right here. So, well, we've got to write down the equation. We have y is equal to 3 times x, but what is x? We said that x is equal to 1. And then we got the plus 1 at the end. Okay, so we got 3 times 1 plus 1. So this is 3 plus 1 is 4. So 4 is our output. And this is the input. There you go. That's it. And then they basically say the same thing for the next one. This is going to be a short video. Okay. What is y when x equals 5? So I always like writing the equation. You got 3 times x, but what is x? 5 plus 1. Whoops. Okay, so we have 3 times 5. This is 15 plus 1. What is 15 plus 1? It is 16. And this is our output. That's it. There you go. So right here we have y. What is y when x equals to negative 6? So basically what we do is just write down the function, which is y is equal to 3x, but x is negative 6 plus 1. Okay, so we got 3 times negative 6, which is negative 18. And then we get that plus 1 at the end. So what is y equal to? Well, it is negative 18 plus 1. That is negative 17. So this is our output. And looks like that's it. Let me see. I guess we can talk about the next part. Might as well. Yeah. Okay, we're going to be talking about proportional relationships. Basically, what proportional relationship means is basically, it says it right, or the definition. A proportional relationship is a relationship between inputs and outputs, which is a ratio of inputs and outputs are always the same. Basically, like if you move a certain amount of, um, say, like or how much you put in. Well, if you double it, then the output should reflect the same type of proportion of going outward. Of say that you get 1 gallon for 30 miles for your car. Basically, if you double that, then well, you're gonna double the gas, which is gonna be two gallons, and then you also double the output. Basically, like it's gonna be the same proportion. You could do another 30. So it's going to be 30 plus 30 is 60. And then say if you did a triple, well, it's the same proportion. It's going up by 30 every single time whenever you increase 1 gallon. So it's the same proportion every single time. Ideally, that's how uh, your car would work. But yeah, that's basically the rough idea of proportion. Let's just see how they do. Right here, they're talking about gas. Um, and the gas cost for 1 gallon of gas it is $3, and 2 gallons of gas is $6. You see how this is three and this is six? Well, it went up. Well, the cost of just one of them is $3, and if you add another one for a gallon, you should increase the cost of gas another $3, which is what's going on here. But the way that they do it over here is by the ratio of gas per gallon. So they're doing it by a ratio of 1 over 3. They're doing it a different way, but it's still the same. They're doing 1 over 3, which is 1/3. Well, the next one is 2 over 6. Well, if you do 2 over 6, that is just still 1/3. And then over here, it is 3 over 9, which is still 1/3. 4 over 12 is still 1/3. You see how these are all the same ratio? That they're going up by the same amount because they're going up the gallons of gas is going up by the same amount. It's being consistent, which makes sense. They're not just gonna charge you that once you get a certain amount, they just like change the price. Well, technically, like usually in like bulk orders, like the more you pay for like a product or something, like say that the cost of something goes down if you buy more of it. Like sometimes I do that. Say that you buy like 300 or like um, the cost of a pencil, or like say that you get a pack of 10 pencils for $1. Well, if you buy um, 100 pencils, you would think that it would cost $10, but they would charge you $5 or whatever. Like it's not something like that. It's consistent. It's proportional. There's nothing like in the real world where it would this would be. Same thing with the gas. It's consistent. Let's see. Over here. Okay. We're doing this. We're just determining the relationship is proportional or not. So we're basing if the ratios are the same. We want to see are these ratios the same? Because if they're not the same, then that means that there's no uh, the relationship is not proportional. So let's write our problems here. So we have one. Okay, I'm gonna rewrite the thing. I don't want to write on the piece of paper. We got -9. Hold on, let me write this down. Okay, so we have this set of points. So we just have to find the proportional. The way that they did it is by this divide by this. They do it in a proportional point of view. So they do the left over the one on the right. So let's just do it that way. So we do 3 over 9, or negative 3 over uh, negative 9. The reason why I said 3 over 9 is just because the negatives cancel, so it doesn't matter. Because when you divide a negative number by another negative number, they cancel out. So it becomes a positive. So this is the same as saying 3 over 9. So what is 3 over 9? That is 1/3. Okay. Now what is negative 1 over negative 3? Well, it's the same as saying, since a negative number divided by a negative number is just the positive version of that. So it's just 1/3, which is exactly the same as this. So far so good. We have 2 over 6, which is just 1/3. And then over here, it's the same thing. We got 4 over 12, which is 1/3. Notice that these are all 1/3. So this means that this is proportional. It is. Okay, now let's do the second one. We got m and n. Don't worry about the different variables. This is still the input. This is still the output. It doesn't matter. You don't have to be worried about the letters. They're just letters. Okay, we got, let's do the same thing. Left over right. Okay, so we got 6 over 8. Okay. Okay, what is 6 over 8? Well, they both have 2 in it, so we can divide a 2 on each one. So this will be 3 over 4. The reason why I say they both have a 2 in it is because there's a multiple. If you divide 6 by 2 is 3, and if you divide 8 by 4, it is 8. Or divide 8 by 2 is 4. So that's how I got 3 over 4. Let's do over here. 15 over 20. There is a 5 in the 15, a multiple of 5 in 15, and a multiple of 5 in 20. So we divide 5 by the top and bottom. So 15 divided by 5 is 3. 15 divided by, or 20 divided by 5 is 4. So 3 over 4. So far so good. These are the same. Okay, we got 24 over 32. Now we got to think a little bit. It's the same idea. We got to find the multiple of the same thing on each one. Well, 8 goes into 24 and 8 goes into 32. So we can divide it. So what is 24 divided by 8? It's 3. What is 32 divided by 8? It is 4. Okay, 3/4. So far so good. Very good. Okay, now we got 36 divided by 48. Okay, now we're getting a little bit more tricky. Now we have, let's see, can we do this? What is the highest multiple that we can get for each of these? Well, in fact, the first thing I thought of was actually 6, but we're gonna get something kind of, we could have saved this step. But the highest multiple that we could find is a 12. There, 12 goes into 36, 12 goes into 48. Okay, so we have to divide 12 by on the top and bottom. Okay, what is 36 divided by 12? 3. What's 48 divided by 12? It is 4. Look, they're all 3, 4, 3, 4, 3, 4, 3, 4. So it is proportional. The reason why I said that, oh, I first thought of 6 is because that's the first thing I thought of was that, okay, if I did divided 6 by both top and bottom, look, I would have gotten 6 on the top and then 8 on the bottom. But look, it's the same thing as this over here, where we did a multiple of 2. So I could have just multiplied. There's a multiple of 6 and a multiple of 2. So if you were to combine that, it's a multiple of 12. I just kind of, oh, whoops. But whenever I think of 36, I think of the number 6. It's just like a habit that I have is the square root, or the square of 6. So I just have a habit of thinking 6 first. That is it for this worksheet. Um, let's see. Yeah, we could talk about the next one. It's related. Okay, I mentioned it earlier, but this is linear functions. Linear functions is just basically like a fancy name, is like where things go at a linear pace. And what is a linear pace? It's just a line. It's a constant line that's going at a constant rate. It's going up a certain way. It's like it doesn't. A line does not do this. It doesn't do that, and then it goes up. A line just keeps going in a perfect straight line. It does not change. It does not do a little curve or something like that, or like some type of squiggly. It's always a straight thing. It's a straight line. They call it, instead of calling it a line, they just call it a linear function. Um, just another way of looking at it. It's the same exact idea. Now we have, here is a function where it is linear. Notice how the way since we talked about proportional, it's going up by the same proportions. It's a constant rate. Look here, we went up 1 and then we moved up 3 on the output. So right here, we moved up 1, we moved up 3. Over here, we moved up 2. So down here, we should move up 6 because we got double of the rate that we changed because we moved up double on the top. So that's exactly what we got. They're all 1/3. They're exactly changing the same amount or the same rate constantly. Now over here, it's not the case. Look, we go up 2 over here, and then we go up 2 right here. We go up 2 over here, but look, we're supposed to go up 2 here, but we actually go up 4 here, and then up 2 here, and then we actually, not up 4, we're actually going plus 6. So this is actually going more, it's, your input is uh, increasing by the same amount, but the output is not increasing the same amount. It's changing. It's actually getting bigger and bigger and faster. So um, this is not a linear function. What's kind of happening is like it's going up faster and faster as you're increasing the value. See how like it's slowly increasing more and more as you're going on. That's basically what's happening here. And we have some examples to see if it is a linear function or not, or if the table is linear. That's what it says. Okay, so let me just write down the problem. Okay, we have from -2 to -4 to -2. This is going up by a +2. Okay, now from here, we're going to from -2 to 3. What is that? That's a +3. Sorry, I kind of did this quickly. I should have done that. I should have wrote it lower. Okay, now from here, we're going from 1 to 5. So this is +4. Okay, now the next one. Look at the bottom. We're going up by plus 2. And then look at the bottom. We're going up by plus 3. Next one, we're going up by plus 4. Notice how we're constantly, like, we're doing the same ratio constantly. Um, it's moving at a constant rate. Um, or actually, hold up. If it moved up by 2, yeah, it is. Okay, just making sure it's it because it looks a little bit odd. Yeah, this is a linear function. Yeah. Hold on, let me make a. It's gonna be negative. Actually, it should be linear because it's going up by. What's throwing me off is because like they're going up by the same amount, but I'm trying to think of an example of it not being the case. Trying to figure out a function that where it works out to be that way. Okay, I guess I just have to do it the old-fashioned way. Okay, we got 2 points. And we want to find the slope. This is our x, this is our y, this is our x to the y. So we're going from here to here. So we got -2, we got a minus the first, first y, minus the first 1, which is 2. This is going to be -2 first, then a negative of this, which is +4. So we have 2 over 2, which is 1. Okay. Now over here, let's do another 2 points. Let's do these 2 points. So if this is the case, then the slope should be just a 1. So we got 1, 3. This is embarrassing. I should have been able to do this in my head, but you know, it's good to work things out first. This is going to be 4 over 4. So it is 1. So there you go. So these are by the same, increasing by the same amount. I can't figure out the function or, well, I can now because once I have the slope, I can figure out the equation. So the equation of a line is y equals the 1 point that we have equals the slope x minus whatever the other point. So we have, say we pick any point. Okay, say that this is our point, this entire thing. So our function is going to be y is equal to -0, which is just that. What is our slope? Just 1. Okay, then we got x. What is our original? So it's going to be 2. So we're going to just get x plus 2. Oh, yeah, that's it. It's going up by this is our function. So yeah, it is a linear function. There you go. Yeah, that's embarrassing. I should have been able to figure out the equation. I knew it was going up by like a constant rate because it's moving by the same, but I couldn't for sure guarantee it. I needed to make sure. So yeah, it's fine. You can just work out problems. needs some time. Okay, from here to here, what has changed? We went up by +1. From here to here, we went to +2. From here to here, we went up by +1. And then let's go from here to here, here to here, here to here. Okay. Now, from 7 to 4, we went down by -3. From 4 to 4, that is 0. From here to here, we went up 3. So notice how we're doing, we went up by 1 from here to here, but we went down by -3. And then from here, we went up by 1, but we went up by +3. So these two alone right here tells you, guaranteed, because if it is a linear, then whenever you do add 1, they have to go by the same amount on the y-axis, uh, by the same ratio. Not, this is like completely opposite. I'm pretty sure that this is a parabola, by the way, that this has the same output, but they have symmetric x coordinates, so it's probably going to be like something like this is at level 4, y equals 4, and this is at 1, this is at -1. It's probably like these are the points where it's going in this direction, because look, these are symmetric. So this is not a linear function, because in order for it to be a linear function, if it goes up by a certain amount, then if it goes up by a certain amount again on the other side, like on the future, it has to go up or down by the same amount, which is not the case. So this is not linear. And this is linear. Okay. That's it for this problem. Yeah, I think I'll stop it here because it's getting a longer video. Okay. Hope you enjoy it. On to the next.